Okay, so today we're going to be talking about a derivative. So the definition of a derivative is changing some function with respect to x over change in x. It's going to be equal to some function of x plus h minus f of x over h. So all this means is that you have some function. We have some original function f of x, right? So let's say we have some line going through here like this. So at this point, this is the line f of x. The line is f of x. F of x also meaning y is equal to some equation. Say it was x plus 2. So all this means is we have some function of x plus h. So h is basically, the best way I can explain it is if let's say x was here at some random point. Let's call that 1, some point 1, right? And we also have some point also right here. And that point in this distance is h. We're going to call this point right here h. So I'm going to actually get rid of this. So that's point h right here. I just arbitrarily chose it to be h. So that's 1, that's h. Or now let's make this x. Let's just call that. That's x and that's h. Okay? So basically the derivative is just saying we have some function at x. So this function right here at x. And then we have this function of x plus h, so x plus this distance h. Okay? And that's going to be, so just at this point right here, this point right here, this point is f of x plus h, and this point is f at x. Now the distance between them from here to here is going to be h, which is why we have h right here. So basically you're just taking the slope of this line. So the slope is rise over run. So basically you're rising. Let me see, so we'll just do, so it's rise over run. So here we run some distance h, and you rise some distance of f of x plus h minus f of x, which is exactly what you have here. You have this rise over the run. That's all a derivative is a slope of a line. So let's say we had some function that was a parabola. And I said, what is the derivative of this parabola at this point? So what this would, a question that would look like this, it would say you have some function f of x is equal to x squared. Let's just call it x squared. And they said, what is the derivative at x is equal to 2? So this point right here would be, x is equal to 2. What's the derivative at that point? It was what the question says. And you would say, well, the derivative at that point is the slope of this line at that point. And that's the derivative. It's just the slope at that point. So that's basically what derivative is, definition of it. So let's just jump right into some basic examples here. Now let's say we have the equation f of x is equal to x squared. Well, the basic way to take a derivative is you need to multiply the exponent by the constant that's in front of the variable. So right here we have a 1. So you multiply the exponent by the constant and then drop the exponent by 1 or minus it by 1. So f prime, now the prime right here is indicating a derivative, okay? And then also another way to display a derivative is to say df of x over dx. That's also signifies a derivative. So that's going to be equal to 2 times 1 is 2, and then you write the variable and then subtract the exponent by 1. So 2 minus 1 is 1. So that's a 1 right there. So I'll just leave it like that, blank. So the derivative of this function, x squared, is 2x. So basically what this means is you have this equation, like you have this parabola like this, x squared, and at any point the derivative is going to be 2x. So let's see, let's take this point 0 right here. Now remember, the derivative is the slope of the line. So the slope of this line at this point, obviously you can say it's 0 because it's flat, straight across. So if we were actually plug in x at 0, so 2 times 0 is 0. So that means exactly what we said, the slope is 0 because you can see it's 0. So again, at any point we can see, if we said here, this is a slope here, like this. And then at this point over here, the slope is like this, negative. So this has a positive slope, negative slope. So what how do we indicate this with this function, with this equation? If we say x is negative, we multiply a negative right here, that gives us a negative slope. If it's positive, then we have a positive slope. So that's basically what it means. So again, I'm gonna stop writing f of x and just put y because it's the same thing. So y is equal to x cubed plus 1. Now the derivative of a constant is 0. Why? Because we just have the equation y is equal to 1. So y is equal to 1. 1's right here. So y is equal to 1. It's a flat line across. That's all it is. So what's the slope of this line? 0 all the time because it's a constant. So let's take the derivative of this one. So again, basic idea is to multiply. So we're going to put y prime. Again, the prime means derivative. So multiply the exponent by the constant in front of the variable. So 3 times 1, 3. Write the variable. Subtract the exponent by 1. So 3 minus 1 is 2. So about this term, well, we said previously that the derivative of constant is 0, so it's 0, so plus 0. So we just erase this, it's just 0, so leave that. So the derivative of this equation is just 3x squared. Now there are other rules for derivatives. So there's one that's called the product rule and the quotient rule. So the product rule looks something like this. If we had 4x squared times 2x cubed, okay, this, you see, this is a product right here because you're multiplying these two. So let's just say, for instance, this equation, we're going to call it f of x, and this equation we'll call it g of x. Okay, so what is the derivative of f of x? This piece here, the derivative of f of x is equal to 2 times 4 is 8. Write the exponent. Write the variable, and now the exponent 2 minus 1 is 1, so 8x. And now what is the derivative of g of x? Well, it's 3 times 2, 6. Write the variable. Then the exponent minus 1, 3 minus 1 is 2. So this is what that is. Okay? So what is, I'm actually going to prove to you why we have a certain rule for the product rule. So why a prime is not equal to f prime of x times g prime of x. So why am I saying this? Well, if we went ahead and multiplied these two, we have these two together, 8 of x times 6x squared. So 8 of x times 6x squared. This gives us 48x cubed. Alright, well, that's not the correct answer. That is not the derivative of this equation. So what is the derivative of this equation? Well, the proper way to do it is, you would say y is equal, you would just multiply these first together, okay, without taking any derivatives first. Multiply them together first. So what is that? We have 4 times 2, 8. X squared times x cubed is x to the 5th. Take the derivative of this guy. 5 times 8 is 40. Write the variable x. 5 minus 1 is 4. So this is the proper derivative. And as you can see, that is not equal to this. So the big moral of the story here is that y prime is equal to f of x times g prime of x plus f prime of x times g of x, and not equal to this right here. Okay, that's the big moral of the story. This is the product rule. Whenever you have two things like this, you have to do it this way. I know that's a little confusing at first, but we'll go ahead and do it again, so just so you can see what I'm talking about here. So again, here the equation is this. This is the equation. For a product rule, you say y prime is f of x, g of x prime. So the derivative of g of x times f of x plus f prime of x times g of x. Okay? So first, so y prime is equal to f of x, so f of x is just 4x squared. And then g prime of x, we did it earlier, g prime of x is 3 times 2, 6. Write the variable. 3 minus 1 is 2. So this is g prime of x. Plus f prime of x. F prime of x is 4 times 2, 8. Write the variable. 2 minus 1, the exponent minus 1. is just x, times g of x, this is just g of x, 2x cubed. So what is that equal to? You see y prime equals to 4 times 6, 24, x to the 4th, plus 8 times 2, 16, x to the 4th, which is going to be equal to 40, x to the 4th, so 24 plus 16. So this, as you can see, this is exactly what we had the last time. And I'll show you real quick again where it was. So 4 times 2 is 8, x to the 5th, derivative of this guy is just, so the derivative of this guy is just 5 times 8, 40, x, 5 minus 1 is 4. So you get the same exact answer here. Okay? So you're probably asking yourself, oh, this is kind of confusing. Where do I use this? Well, you use it when you have, let's just say this is when you really need to use it. Alright, so again, so then here's the, I'm gonna go ahead and show you the quotient rule. So the quotient rule says you have, let's say you had f of x, some function with respect to x or just y, is equal to, let's say, 1 over x squared, like this. So the quotient rule says if you have you know, a variable in the denominator, or in the if you had a variable in the denominator and the numerator, then you would say f prime of x is equal to, it's going to be the bottom one, so I'm just going to put in general here, this would be g. Call it g of x, whatever you want. So it'll be, and I'm gonna put this one up here, I don't know, just call it h of x, right? Something, I'm just making it up. So it would be g of x times h prime of x minus g prime of x times h of x all over g of x squared. So for example, if we had f of x is equal to 1 over x squared, this would be, so f prime of x following this equation, so g of x in our case is x squared. So write it, we have x squared. What's the derivative of a constant? 1, which is h of x in our case. Constant 1 is 0, minus g prime of x. So derivative of g prime of x is just 2x times h of x, in our case is 1, all over g of x squared. So x squared squared, which is x to the 4th. Okay, now what's that equal to? This is 0. So this is equal to negative 2x over x to the 4th, which equals to negative 2 over x cubed. Okay, so as you can see, that's the answer. Now that was a long way using this equation. Now a shorter way would have been to do this. F of x is equal to, I'm going to move the denominator to the numerator. So x to negative 2 times 1, whatever. So then f prime of x is equal to negative 2 times the constant 1, it's negative 2. Drop the, you do negative 2 minus 1, so drop the exponent by 1, so negative 2 minus 1 is negative 3. Equal to negative, this equal to negative 2, or move this term here down back to denominator, that way you have a positive exponent, so x cubed. Now as you can see, you get the exact same answers. Okay, so that's the quotient rule and the product rule. And I'll probably do some more videos for you, a little more on more examples, so you can get a better feel for this. But I just wanted to introduce it to you for now. But the big takeaway from this is, remember that the derivative is just the slope of a line. That's what it is. Slope of a line. So if I have this right here, again, it's just, if I want it at this point, it's the slope of that line. That's all it is. At this point, the slope of this line, running through that point. That's the derivative. So I'll just go through a little quick example with you that's on your, I guess, on your practice test. Something that you would see. It says, which of the following is an equation of the line? So, an equation of the line tangent to the graph f of x is equal to x cubed minus x at the point x is equal to 2. So what does this mean? Okay, what is the, I don't remember what the graph of x cubed looks like. I believe it looks something like, well, I won't draw it for you because I don't remember what it looks like. So what's tangent mean? So we have this line tangent. All tangent means, again, so if we had some crazy line like this, and at this point x equals 2, so this point, tangent means this line that is just barely touching it, like barely touching it, tangent. So a better depiction of it would be like this: tangent of lines. Pick that point. Tangent means it's running, touching the graph. It's touching it, like this. If this was tangent, it'd be like this. Tangent, like this. Same thing. That's what tangent is. It's barely touching it at some point. So to do this, so if it's tangent, it wants to know the equation of it. So what's the equation of a line? So the equation of a line is y2 minus y1 equals to m of x1 minus x2. That's the equation of a line. Okay? M is the slope. The slope, m. So what did I say? What is the derivative? Is the slope. So we're going to take the derivative of this equation to get the slope m. Okay? So let's do that. So f prime of x is equal to, so 3 times the constant in front is the constant is 1, so 3 times 1 is 3, x, drop the x 1 by 1, squared, minus, we have an x. So this x has the power to the 1. So 1 times the 1 is just the 1. X to, and then we have to drop the exponent. So I write the variable. I have to drop the x 1 by 1. So 1 minus 1 is just 0. So 0. So anything to the power of 0 is 1. So x to the power of 0 is 1. So we just have a 1 left here. That's the equation. This is the derivative of this equation here. So at the point x equals 2, what is that slope? Remember, this is the slope. This is equal to m. Okay, so f prime of 2. So 3, 2 squared minus 1 equals 3 times 4 minus 1 equals to, this is 12 minus 1 is 11. The slope m is 11. So let's plug into this equation here. So what's y2? Oh, we don't know y2, so this is going to be y2 minus y1. What is y1? Well, oh, okay. In order to get y1, we had to plug into this equation here. So we have f. This basically, I'm sorry. So we have y is equal to x cubed minus x. So we have to plug in x equals 2 to find our y1 here. So we need to find y1. We don't know y1. We need to find it. So this would be y1. This is x1. This is x1. So we need to know x2. Ooh. Oh, I'm sorry. y1 minus y2. Oh, I'm sorry. Oh, I'm sorry. Here, I got this one backwards. My bad, honey. x2 minus x1. Sorry about that. I was tripping out right there. So we don't know y1. We need to find it. We don't know y1. We don't know y1. So we have x1. x1 is 2. Okay. So this equals to 2 times 2 cubed is 8 minus x1, which is 2. This equals to 6. Okay. So y1 equals 6 with x1 is equal to 2. Okay. We're going to plug that in over here into this equation. So we have y2 minus y1, which is 6, is equal to m, which is our slope, times x2 minus x1, which is 2. And this is our equation. This is the equation of the line tangent to that graph at x equals to 2, at the point x equals to 2. Okay? So I hope I didn't confuse you on that one. So what you needed to do, step 1 was, write the equation of a line, which is this guy. This is step 1. Write the equation. Step 2 should have been to take the derivative. So here's the derivative to find the slope. Step 3, find y1. This is 3 right here. Find y1 with given x1 right here, which is 2. Okay? Plug it into there, get y1, you get this. Now the final step, step 4, is actually plug everything in. Plug in your slope, plug in your y1 and x1 into your equation. Okay? Plug it in and this is your equation. That's your answer. Okay? Hope that's as helpful.